What's up, guys? It's Mr. Wicklehouse, and today we are going to talk about some triangles and the relationship between the sides of the triangles and their angles. Okay, so here we go. Here's some ideas that you need to be thinking about. So the longest side of a triangle is opposite its largest angle, and the shortest side of a triangle is opposite its smallest angle. Also, the largest angle is opposite the longest side, and the smallest angle is opposite the shortest side. That being said, let's figure out what the longest side is, the largest angle, the shortest side, and the smallest angle. Okay, so what's the longest side? Well, the first thing I want to do really is figure out what the largest angle is. Well, 55, 60, 65, so angle C is the largest angle, which then means that the side opposite of that is the longest side. So side AB is the longest side. Now let's figure out what the shortest side is. Well, the shortest side is going to be opposite of the smallest angle. Well, the smallest angle is right here, angle A, at 55 degrees, which means then that the side opposite that, BC, is the shortest side. Okay. That's really all there is to that. So let's talk about a couple theorems. If one side of a triangle is longer than the other side, then the angle opposite the longest side is larger than the angle opposite the shortest side. Which that just makes sense. It ties into what we just said. Obviously, the larger angle, or rather the longer side, is going to be opposite the bigger angle, and the shortest side is going to be opposite the shortest angle, or the smallest angle. And so that means that this angle is going to be bigger than that one. Okay? Alright, here's another theorem. If one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the shorter angle. Okay, same idea as up here, they just flipped it around so that we're talking about sides instead of angles. So up here in this one we're talking about angles, this one here we're talking about sides. Let's use those things to talk about some ideas. So, example 1, write the sides of the triangle in order from shortest to longest. Alright, first thing I want to do is I want to go ahead and find this third angle. That way I'll know what all the measures of my angle are. So this is 60, this is 62. Remember that all three angles of a triangle add up to be 180. 60 plus 62 is 122, minus 180, that's going to be 58 degrees. Okay, well 58 degrees is the smallest angle, so this side opposite the 58, BC, is going to be my shortest side. So BC is going to be less than the next shortest side, which is the next smallest angle, which is 60. Okay, so smallest, next smallest, largest. So that means AB is the next smallest, which means 62 being the largest angle means that AC is the longest side. So BC is the smallest or shortest, AB is the one in the middle, and AC is the longest. Longest, middle, shortest. Pretty easy. All you're doing is looking at the side opposite of this, measure the angles and matching that stuff up. Okay? Okay, now here's another side of the coin. And it says, write the angles in order from smallest to largest. So basically, we're doing this in reverse. And they give us the length of the sides. This is 7. This one's hard to see. It's 10. This one's 11. Okay? Which means the angle opposite the 7 is going to be the shortest angle, which is angle V. That's smaller than, or less than. 10 is the next smallest size, so that's opposite of T. So angle T is the next smallest angle, which means that angle U is the biggest angle. That's it. That's all for that idea. Okay? All right. So this is called the triangle inequality theorem. And what it says is that the sum of the lengths of any two sides of a triangle is greater than the third side. So the easiest thing to do is going to be to start with the two smaller sides, and if they satisfy the theorem, then the remaining sums will also satisfy it. We're going to use this to determine if things are triangles or not. Okay? So for this example, it says, could the following be the side lengths of a triangle? So what you want to do is you want to find the two shortest lengths, so 18 and 12. Okay? And we're going to add those together, so 18 plus 12, and we're asking, are those greater than the length of the third side, which is 27? Well, 18 plus 12 is 30, and yes, that is greater than 27, which means that this is, in fact, a triangle. Is a triangle. Okay? That's all we're doing. We're picking the two shortest sides and we're seeing if they're greater than the third side. Okay. Let's look at this one. This is 5 and 7. So 5 plus 7, is that greater than 14? Well, 5 plus 7 is 12. Is 12 greater than 14? No, it's not. So this is not a triangle. It's impossible for that to be a triangle. Okay, here's a tricky one. Students get hung up on this sometimes. 12 and 14 are my shortest sides. 12 plus 14, is that greater than 26? Well, 12 plus 14 is 26. Is that greater than 26? It is not greater than 26. It's equal to 26, but not greater than. Since it's not greater than, it is not a triangle. Okay. Alright. Here's another example. 2.001 plus 3, is that greater than 5? 2.001 plus 3 is 5.001. Is that greater than 5? Not by much, but it is greater than. So this is a triangle. Okay. Last example, square root of 5 is smaller than 5. 2 is smaller than 5, so those are the two I'm adding together. Square root of 5 plus 2, is that greater than 5? Oh, lights went out. Okay. Square root of 5 is 2 point something something something. So that means that this, if you don't believe me, put it in your calculator, do the square root of 5 plus 2. This is actually not greater than 5. It gets kind of close, but it's 4 point something. I don't know off the top of my head. So this is not a triangle. Okay? Alright. Let's do some more examples here. Example 4 says find the possible values for the third side of the triangle. Okay, so this is going to be a range of values. We're going to be using inequalities here. So this is what we need to do. I know that 16 plus 11 has to be greater than x. And these are the possible larger sides, so this is what I'm going to do here. So I do 16 plus 11, that's 27, has to be greater than x. So I know this third side has to be less than 27 inches. Okay. Alright. Now we're going to go on the opposite end of that and get the small side and make it the smaller side. Okay. So what I'm going to do is I'm going to take 11 plus x, and I know that that has to be greater than 16. Okay. Which means that if I subtract 11, I get x has to be greater than 5. So then, the range of values that I have for x are anywhere from 5, which is the small, it's got to be bigger than 5. That's the smallest end. And it has to be less than 27, because if it's bigger than 27, then these two won't add up to be bigger than it. Okay, so the possible values for the third side is somewhere between, any number between 5 and 27 will give me the triangle. Okay? Alright. Now, let's look at this one and do this one together. It's the same idea. They call this question mark. I'm going to change it to x because whatever. Alright. 7 plus 11 has to be greater than x. 7 plus 11 is 18, has to be greater than x. Okay. Also, I'm going to pick the shorter side with the x and add those. So 7 plus x, that has to be greater than 11. Subtract the 7, I get x has to be greater than 4. So, my range of values for the third side for this one is going to be 4, has to be less than x, which has to be less than 18. There's my range of values. Okay? That's basically all you're doing. You're setting up a couple inequalities. One where you add the two sides and set them equal, greater than x, and then the other one you take the smallest side and the x and make sure it's greater than the other side. And that'll give you a range of values every time. That's basically what we're doing with these. That's it. I will talk to you later.